Hey viewers, this is VCube here. Today we'll be discussing how to graph some of different modulus functions. So let's get started. So today we'll be graphing modulus of x minus 2 plus modulus of x plus modulus of x plus 2. Alright. So in order to understand this, let me just draw the modulus graph first. Basically a V-shaped graph. So the graph is split up into two components. So your first component is simply y is equal to x, and your second component is y is equal to minus x, which is getting split at x is equal to 0, right? So this is your x and your y axis. So similarly we can also draw your other graphs. So let me draw y is equal to modulus of x plus 2 graph over here, since I have drawn modulus of x graph over here. So here we are having modulus of x plus 2. So you can draw the same modulus of x graph, but you'll have to make a small change. Since the plus 2 has been added inside the argument of the function, the graph shifts. It is simply your y is equal to modulus x graph, but shifted towards your left by 2 units. Alright. So if I shift this graph over 2 units, I'll be having my x-intercept to be minus 2, and then you can draw your V-shaped graph over there just like that. Or you can probably find at x is equal to minus 2, your value of the function is to be found to be 0, right? So in your x-intercept you can start drawing your V-shaped graph. The function is again split up into two different components. See, when x is greater than minus 2, the entire x plus 2 expression would be positive. So there is no need to change anything as it is already positive. But if it is less than minus 2, your entire x plus 2's expression would become negative. So I need another negative sign in order to make the already negative term to be positive. And that is the reason why we are writing minus of x plus 2. And that is the reason why we are writing y is equal to minus of x plus 2, because x plus 2 is negative when x is less than minus 2, and by plugging in another negative sign we will be making that expression to be positive. So same theory can be applied for your y is equal to x minus 2 as well. So we are going to draw y is equal to x minus 2 graph over here. So it is simply the y is equal to modulus of x graph, but it's shifted towards now right by 2 units. Yes. Now the graph has been drawn. So this is your graph, and again it is split up into two components. So this is y is equal to x minus 2, and this should be y is equal to minus x plus 2. So we just drew three functions. Now it is our duty to split up the entire intervals, right? So what we are going to do now is, let me just draw a real line. It is going to have getting split. So it is your minus 2, then it is your 0, then it is your plus 2 on your real line. Now what we'll be doing is, we'll be examining the values on different intervals. First interval is minus infinity, less than x, less than minus 2. So minus 2, right? So we'll just simply look at the graph. So minus 2 is somewhere over here, and it is over here, and in this function it is over here. So for minus 2, all the three graphs are showing your left side of the function. So the left side of the V part. So you will be writing the negative portion of the functions for all the three functions. For all the three functions. So you will be having minus x plus 2, and for your second piece you will be writing minus and for your second function you will be writing minus x, and for your third function you will be writing minus x minus 2. So this results to your 2 and 2 gets cancelled. So this results to minus 3x. And now we'll examine for this interval, which is minus 2 less than or equal to x less than 0. Equal to can be put up over here as well as here. So we know that it is a continuous function. So now, yeah. So minus 2 to 0, right? So minus 2 to 0, for your first function, we are again on the left side of the v. And for your second function, again we are on the left side of the v. And for your third function, we have moved to your right side of the v, which is when x is between or when x is above minus 2, your graph of y is equal to modulus of x plus 2 will start taking the positive value, which means in the analytical representation of the function, we won't be simply having a negative sign because the answer is already positive. The existing answer itself is positive. So there is no need to have a negative sign over there. So we'll simply just start adding up the graph. So as I mentioned earlier, for your first graph, it's the left side of the v, so it's minus x plus 2. And for your second graph, it's again left side of your v. And for your third graph, it is right side of your v, so it is x plus 2. So you'll be having 4 minus x. Similarly, for your next piece, which is 0 less than or equal to x less than or equal to 2, right? So 0 to 2, again let us examine 0 to 2 over here left side, 0 to right side, 0 to 2 right side. So left side of your function is minus x plus 2, and for your second function it is x, and for your third function it is x plus 2. So we can simply cancel minus x plus x, and you'll be having your answer to be 4 plus x. And this is your final piece. So in your final piece, all the graphs have taking the right side of the v. The right side of the v is taking part, right? So x minus 2 plus x plus x plus 2. So you will be having up 3x over here. So this is your final function, and it is enough to draw the graph of this. Let me have this to be a minus 2 plus 2 and then 0. We'll start off by drawing your second portion. So your second portion is from 0 to 2, right? Or sorry, we'll draw with third portion 0 to 2, right? So between 0 to 2, I'm going to draw y equals x plus 4. So let me simply plug in 0 and 2 over here because it is going to be between 0 and 2. So the answer would be 4 and 6. So 2, 4 and 6 will be coming up over here. So you'll be having your 2 points, your 0 comma 4, and then your 2 comma, it is simple. Alright, now we'll be drawing your graph of your second piece, which is minus 2, again x. When it is between 0 and your minus 2, we are going to draw a 4 minus x graph. So it would be 4, and this one would be again 6. So you'll be having 0 comma 4, and now minus 2 comma plus 6. So minus 2 comma 6 over here. We'll have to draw y equals 3x. So 3x, it can be drawn easily. X is simply a straight line with the angle of inclination 45 degree. So the curve would be, 3x curve would be something like this. This would be a 3x. So as you can see, you're having y is equal to 3x over here, y is equal to minus 3x over here, y is equal to 4 plus x over here, y is equal to 4 minus x. So once you have an understanding of the graph, you can solve these kind of graphs in seconds. So I hope you learned something new from this video. Subscribe us for more such content. Thank you.